Every luxury lipstick begins its journey far from the factory floor. Here, in these lush pastures, the water buffalo graze peacefully. Their horns, rich in keratin, will soon be transformed into the structural base for our premium lipstick casing. Buffalo horns are composed mainly of keratin, a protein that provides both strength and natural flexibility. This makes them ideal for crafting durable yet luxurious lipstick tubes. Once harvested, the horns undergo meticulous cleaning. Any impurities are removed to ensure purity, preventing contamination that could affect the lipstick's quality or safety. Next, the horns are cut into precise segments. This stage requires both engineering accuracy and artisan skill, ensuring that each tube base will be perfectly aligned and structurally sound. While the horns form the casing, natural waxes, often beeswax or candelilla, are heated to a precise temperature. This controlled melting ensures consistent texture, essential for smooth application in the finished lipstick. Pigments are carefully integrated into the wax. This is where chemistry meets artistry. The even dispersion of color ensures that every swipe of lipstick delivers the exact shade intended by the designer. Before molding, every batch is sampled. Temperature, viscosity, and pigment saturation are checked to guarantee consistency. Luxury lipstick demands perfection, even at the earliest stages. Finally, the prepared materials are carefully stored under controlled conditions. This ensures stability, ready for the next stage, molding into the iconic lipstick shape. After the raw materials are prepared and the cosmetic formula is stabilized, the process moves into one of the most critical stages of lipstick manufacturing: precision engineering and molding. Inside the factory, highly controlled production lines transform liquid cosmetic mixtures into perfectly shaped lipstick cores. Every step must be carefully monitored, because even small changes in temperature or viscosity can affect the final product. The process begins with the preparation of the lipstick molds. These molds are typically made from polished stainless steel and designed with extreme precision. Their smooth surfaces allow the lipstick to release cleanly once it has solidified. Next, a heated lipstick mixture, a blend of waxes, oils, pigments, and stabilizers, is poured into the molds. At this stage, the material is still in liquid form, allowing it to flow evenly into every contour of the mold cavity. But pouring alone is not enough. The molds must then pass through a controlled cooling system. As the temperature gradually drops, the wax structure begins to crystallize. This controlled solidification ensures that the lipstick maintains its strength while preserving a smooth, flawless surface. If the cooling happens too quickly, microscopic cracks could form. If it happens too slowly, the lipstick might lose structural consistency. That is why industrial cooling tunnels are carefully calibrated to maintain the perfect balance. Once the lipstick cores are fully solidified, automated ejector systems gently release them from the molds. This step requires delicate mechanical precision to avoid damaging the freshly formed cosmetic sticks. The solid lipstick cores are then carefully aligned and inserted into their prepared horn casings. At this point, craftsmanship meets engineering, combining the natural material of the casing with the scientifically engineered cosmetic formula inside. What emerges from this stage is the recognizable shape of a luxury lipstick, ready for testing, finishing, and final refinement. And although it may appear simple from the outside, every lipstick stick represents a precise combination of chemistry, temperature control, and mechanical engineering working together in perfect harmony. At first glance, lipstick may seem like a simple cosmetic product, but behind every shade lies a carefully engineered balance of chemistry, color science, and material physics. In the laboratory, cosmetic scientists focus on one critical objective: creating a formula that delivers consistent color, smooth texture, and long-lasting performance. The process begins with pigment dispersion. Cosmetic pigments are extremely fine particles that must be evenly distributed throughout the wax and oil base. If the particles cluster together, the lipstick may appear uneven or streaky during application. To prevent this, specialized mixing equipment breaks apart pigment clusters and spreads them uniformly throughout the formula. This process ensures that every section of the lipstick contains the same concentration of color. Temperature also plays an essential role. The mixture must remain within a narrow thermal range so that waxes stay fluid while pigments remain stable. Even a small variation in heat can affect how the formula spreads or solidifies. Scientists also measure viscosity, the thickness of the mixture. If the formula is too thick, it will not pour smoothly into molds. If it is too thin, the final lipstick may become too soft and lose its structure. Another important factor is stability. Lipsticks must maintain their color and texture even when exposed to different environmental conditions such as heat, humidity, or light. To achieve this, chemists introduce stabilizing ingredients and emollients. These compounds help the lipstick glide smoothly across the lips while preventing the pigments from fading or separating over time. Each batch is tested repeatedly to confirm that the color intensity, texture, and melting behavior remain consistent. Because in luxury cosmetics, the difference between an average product and a premium one often comes down to microscopic details invisible to the human eye. And it is here, inside the laboratory, where those details are perfected through science. Before a luxury lipstick can reach the market, it must pass through a series of rigorous quality control tests designed to verify both its safety and durability. In the Quality Assurance Laboratory, technicians examine each production batch to ensure it meets strict cosmetic industry standards. Even the smallest imperfection can lead to rejection. One of the first evaluations focuses on structural durability. Lipsticks are subjected to controlled drop tests that simulate accidental falls during everyday use. Engineers analyze whether the lipstick core cracks, bends, or separates from its casing. Temperature resistance is another critical factor. Lipstick must maintain its form, whether stored in a warm handbag or a cooler environment. To evaluate this,